Okay, so what if I told you that you could turn a catastrophic multi-million-dollar IT disaster into something you could fix during a coffee break? I'm talking about going from weeks of panic to just 15 minutes of recovery. Sounds impossible, right? Well, today we're going to dive into how it's not only possible, but it's being done every day, all thanks to something called infrastructure as code.
And look at this. We spent 3 weeks rebuilding production after disaster. This isn't some hypothetical nightmare scenario I'm making up. This is a real quote from a real team whose data center literally caught fire. Everything gone. This is where our story begins, folks. The absolute worst-case scenario when you're managing all your systems by hand.
So let's break that down because the difference is just staggering. On one side, you've got the old way, manual recovery. We're talking 3 solid weeks of pure chaos. Engineers are scrambling, trying to remember server settings from memory. It's a mess. And the result, a $2 million hit to the business and a whole lot of angry customers. But then, look at the other side. With infrastructure as code, that exact same disaster is a 15-minute fix. Seriously, 15 minutes. So the big question is, how?
All right, so how do we make that leap from a 3-week disaster to a 15-minute fix? It all comes down to one big, powerful idea. You need to start thinking about your entire infrastructure as a blueprint, just like for a building.
And this really breaks it down perfectly. Think about it. The old manual way, it's like trying to build a skyscraper by just shouting instructions at the construction crew. Hey, put a wall over there. I think we need a window here. Things get missed, people forget details, and you get what's called configuration drift. Now, imagine that skyscraper burns down. How do you rebuild it? You're just guessing. But with infrastructure as code, you have the architectural blueprint. It's written down, it's precise. Every single server, every network rule is documented. You can rebuild that exact same skyscraper or 100 identical ones perfectly every single time.
So, when we boil it all down, that's what infrastructure as code, or IaC, really is. It's the practice of managing and setting up all your tech, your servers, your databases, your networks, through code files. Simple text files that a machine can read. It takes all the guesswork and, the art of system administration and turns it into a repeatable science. Okay, so how does this actually work? Let's take a popular tool, Terraform, as an example. The whole process follows our building analogy perfectly. First, you run a command called Terraform plan. This is like you and the architect reviewing the final blueprint. It shows you exactly what's going to be built, changed, or even demolished. No surprises. Once you're happy, you run Terraform apply. That's you giving the green light to the construction crew. They go off and build everything exactly as the plan says. And then you get the Terraform state file. Think of this as the final certificate of occupancy or the inspector's report. It's the official record of exactly what was built, a perfect snapshot of your live infrastructure.
Right, so we've got this idea of a blueprint, but how do we actually write it? What's the language we use to tell the cloud what we want?
And this is a really, really important concept to grasp. There are 2 ways to do this. The old way is called imperative. That's where you have to write out every single step. First, create a virtual machine. Then, attach a network card. Next, install this software. It's exhausting and super error-prone. But IaC uses a declarative approach, which is way smarter. You don't say how to do it. You just say what you want the end result to be. I want 3 web servers with these specs. That's it. You declare your destination, and the tool figures out the best way to get there. And here's what a little piece of that blueprint actually looks like in code. Now, don't get scared off if you're not a coder. Just look at how readable this is. It's basically just saying, hey, Terraform, I need a resource. It's an AWS server. Oh, and I want 3 of them, and they should be this size. That's all it is. It's not a complex algorithm. It's just a clear, simple declaration of what you want. Okay, theory is one thing, but let's get into the real world. Now that we know the what and the why, we need to talk about the how not to do it, because it's really easy to shoot yourself in the foot. So we're going to go through 4 super common mistakes that beginners make that can totally wreck all the benefits we've been talking about.
First up, mistake number 1. This one is huge. Remember that state file, the final inspector's report for our building? A huge rookie mistake is keeping that file just on your own laptop. Think about it. If your laptop gets lost, stolen, or the hard drive dies, you've just lost the only official record of your entire production infrastructure. It's gone. The pro move, the only move, is to use a shared remote place to store it with locking so your whole team can work safely without stepping on each other's toes.
All right, mistake number 2 is just as scary. and that's running Terraform apply blindly without checking the plan first. This is the equivalent of walking onto the construction site and just yelling, "Start demolishing stuff," without ever looking at the blueprint. You could accidentally delete your entire production database with one single command. I'm not kidding. The pro move is a simple rule. Always run Terraform plan first. Always. Get that preview, see exactly what's about to happen, and then, only then, do you apply.
Okay, next up, mistake number 3 is all about being rigid. It's when you hard code values directly in your blueprint. You write environment equals production or server size equals t3.large right into the main file. Well, you've just made your amazing blueprint useful for only one specific building. What about when you need a smaller one for testing or a staging environment? The pro move is to use variables. That way, your blueprint is flexible. You can use the exact same code to build your tiny dev setup and your giant production fortress just by plugging in different values. And last but not least, mistake number 4, the dreaded copy and paste. You build out a perfect network configuration. It's hundreds of lines of code. Then you need another one, just slightly different. It is so tempting to just copy that whole block of code and paste it. But now, if you need to make a change, you have to do it in 2 places, or 10, or 100. It's a nightmare waiting to happen. The pro move is to create reusable modules. Think of them like Lego blocks or prefabricated building parts. You design the perfect kitchen module once, and then you can just drop that same kitchen into any house blueprint you build in the future. It's clean, efficient, and way safer.
So, when you put it all together and you avoid those common traps, what's the big payoff? Why should you bother with all of this? Well, it's simple. It's about turning your fragile, hand-built infrastructure into an absolute fortress.
And this is why it's a game changer. You get speed, insane speed, like that 15-minute recovery we started with. You get consistency because the code does the same thing every single time, eliminating human error. You can scale up or down from 1 server to 1,000 without even breaking a sweat. And maybe the most important thing of all, you get a disaster recovery plan that isn't just a document sitting in a binder somewhere. It's a living, breathing blueprint that you can execute with a single command.
So I want to leave you with this one question. As you think about everything we just covered, I want you to honestly ask yourself, what is your infrastructure right now? Is it a house of cards built on someone's memory and a series of manual clicks, just one bad day away from collapsing? Or is it a fortress built from a clear, repeatable, and powerful blueprint?